this tutorial, we will be discussing factors that affect the activity of enzymes. So there's several different areas that can destroy an enzyme. One is temperature. Everything has an optimum temperature for it. For humans, it's 37 degrees. They have very little activity below this, and above this, denaturation occurs where it breaks everything down, breaks the enzyme down. Another area is the pH. Once again, there's a specific pH range, and it's not necessarily always that of a neutral. Sometimes enzymes work better in a more acidic environment or a more basic environment. It all depends on what that enzyme is designed for. But if you go beyond that, the ability to do its job decreases. So just to give you an idea of enzymes, the pH of blood is typically around a 7.4. It's a little bit basic. But if we start looking at enzymes in the stomach, it should be 1.5 to 2. If we look at enzymes in the liver, it should be more basic, like 9.7. Alright, so sucrase has an optimum temperature of 37 degrees and optimum pH of 6.2. What's the impact if we change either one of those variables? So if we change the pH from a 6.2 to a 4, it's going to decrease. If the reaction is actually running at 70 degrees instead of 37 degrees, once again, it's going to decrease. In fact, it could probably denature at that point and just completely break down. Inhibitors are molecules that cause the loss of catalytic activity. They prevent substrates from fitting into the active sites where the reaction actually occurs. A competitive inhibitor, see here with the inhibitor, actually gets in the way. It competes with the substrate, hence the term competitive. Has the structure that is similar of that of the substrate. It competes with the substrate for that active site and has its effect reversed by increasing the substrate concentration. So what this means is that when this occurs, you get the enzyme and the product, and that's good, and the enzyme could go catalyze something else. But when the inhibitor is in there, it never actually gets back into the environment that it's supposed to do the reactivity with. Because of that, there's all kinds of substrates rolling around and not as many enzymes. And so that's why you get a bigger concentration of the substrate. So here we have the competitive inhibitor. This in particular one is the induced fit. Here we have the active sites. For the substrate, it fits in there nice and easily. The enzyme comes out, so does the product. For the inhibitor, notice it has a similar shape, and so it confuses the enzyme, and so it never gets to the next step, and it can never be reused. A non-competitive inhibitor has a structure that is much different than that of the substrate. It binds to the enzyme at a site other than the active site. So the competitive binds at the active site. The non-competitive binds it somewhere else on the enzyme. And it ends up changing the shape of the enzyme by altering the shape of the active site. And it prevents the binding of that substrate. It cannot have the effect reversed by adding more substrate. So adding more of the reactants isn't going to help it any. So here, once again, the enzyme and the enzyme. Notice that there's no similarities at all in these shapes. So instead of binding up here, it ends up binding at the bottom. It's not in the same spot. It's not in the active site. But in the process, it's forcing that enzyme to rearrange itself, and so now the substrate can't fit in anyways. Irreversible inhibitors is a molecule that causes the enzyme to lose all activity. is an often toxic substance that destroys the enzyme altogether. It usually forms a covalent bond with the amino acid side chain, preventing catalytic activity. For instance, it could be a nerve gas or an insecticide or an antibiotic, just as a couple examples. Okay, so here's the three kinds. We have competitive, non-competitive, and irreversible. So the shape, with the competitive it's similar, for the non-competitive it's not, and for the irreversible it's not the same shape because it's a different compound. It actually destroys it. Binding to the enzyme. The competitive goes to the same active site. The non-competitive goes to a different site on it and changes the shape of the active site. And the irreversible forms a covalent bond with the enzyme, so it actually changes the reactivity of it by changing the compound altogether. The reversibility, adding more substrate could reverse the inhibition. The non-competitive is not reversed by adding more substrate, but you could do a chemical reaction to remove the inhibitor. And then the irreversible is permanent. Identify each description as an inhibitor that is competitive or non-competitive. Increases substrate, reverses inhibition. This is competitive. It binds to the enzyme surface but not at the active site. That's non-competitive. Its structure is similar to that of the substrate. That's competitive. The inhibition is not reversed by adding more substrate. And that is non-competitive.